All right, we're going to do some problems here, starting on page 673. We're going to do number 12 here. And basically, you've got a circle, and the directions say solve the value for x. And x looks like just a radius here. Looks like we've got a chord, 90 degrees. With this chord that says all the way across 8, since I'm 90 degrees with the radius, it's split. Instead of 8, it's now 4 and 4 on both sides. But how are we going to figure out x? This is the radius of a circle. Well, you're going to need to draw a new radius to help you solve this particular problem. All radiuses are the same, so whatever I draw here, and I'm going to draw this one here, this is also x. So what I have now is basically a right triangle. I'm enlarging it here. 90 degrees, 3.6, half of 8 is 4, and then that's x. And so you would simply go a squared plus b squared is equal to x squared. And then you can go solve that. And that's the basic setup for number 12. Okay, here is number 18. And in 18 it says find the measurement of AB, arc AB. So we want to figure out how many degrees it is from here to here. Is it 100 degrees, 80 degrees? Obviously going around the entire circle is 360, but what is that amount? There's not a single number in this picture here, but we have from the radius OB, that's a radius, and I'm going to draw this radius here, O to A. And again, this here is a radius, and it splits this particular chord AB in half. So this is the same. If I continue on, I'm going to put an x here because I'm going to figure out that x degrees. This is a central angle. And if central angle here, whatever this x is, it's going to be the same as this arc measurement. So if I find out that this is 60 degrees, then this arc here is also the same, 60 degrees. By the way, this is split perfectly, so this is also x. And again, if I can figure out what x is, that will be this side of the pink arc, AB. So I need to figure out the measurement of this inside angle there. If you look at this carefully, I'm going to enlarge this triangle here. Here's O, here's B, here's 90 degrees. But more importantly, tick mark, tick mark. Well, that means it's an isosceles triangle. That means this angle is equal to this angle. And if it's 90 degrees here, this must be 45 degrees. 45, 45, 90. So this is 45 degrees. This is 45 degrees, which makes it 90 degrees in the middle. And that also makes this entire pink arc 90 degrees. So AB is 90 degrees because we have a 45, 45, 90 degree triangle. The angles inside match the arc. All right, we're going to do number 19 here, perhaps the hardest one. We're going to try to figure out the arc measurement here. How many degrees is it between A to B? We have this radius that's going to split this thing perfectly in half. I'm going to also connect the center to B here. And we're going to try to figure out the angles in the center angle, because the center angle is going to match up with the arc. So I'm going to put an X here. If I can figure out angle X, this is also angle X. If this is angle X, outside here is X. If this is angle X, the same can be said with the arc. The center angle and the arcs are the same. The key here is how we're going to figure out angle X. So let's look at this picture here. It is 30 all the way across on this chord, and so it is half of that, 15 and 15 on the left and the right. I'm going to enlarge this triangle here. So if I focus in on this one triangle, this is where the X is. This is 90 degrees. This is 17. This is half of 30. This is 15. I'm going to use some trigonometry to help figure out this unknown angle here, where I'll put this yellow angle here, which is right here as well. And if I stand here at angle X, this 15 is opposite. This 17 is the hypotenuse. We're going to use some trig. SOHCAHTOA The one that uses opposite and hypotenuse is sine. So we're going to say sine angle x opposite 15 over hypotenuse 17. If you'll recall, you've got to use inverse sine when you have the missing angle. And from here, I'm just going to use the calculator. Inverse sine, let me see if I can get it on the screen. 15 is the opposite, 17 is the hypotenuse. The angle x is 61.9. 61.9 in the middle, 61.9 over here. Together, that is the center angle, and the arc it hits is the same. So this is 61.9, this is 61.9. I just multiply by 2 here, and you get 123.8 is arc AB. Arc AB from here to here is 123.8 because it's 61.9, 61.9 here, 61.9 here. Together it's 123.8. Okay, we're going to look at number 30. 30, 31, and 32 are all similar. You're going to see these two circles here. They are congruent. CD is a chord here to both circles. And that's pretty much. We've got two congruent circles, and we've got this CD coming across. It says AB is 4. So here to here is 4. This guy is a chord, which is going to split this guy in half. So it's going to be 4 and 4. I don't know if we need that. CD, the chord is 6, and it's also split in half, 3 and 3, if I want to say 3 up, 3 here. So we've got 8 all the way across. We've got 6. Find the radius. And it doesn't really matter which circle because they're the same circle. So the key is, where's the radius? Now you could go, well, A to here, that's the edge of this circle. And it looks like it goes a little bit beyond halfway because I know this is 4, half of 8. So it looks like it goes a little bit halfway. That's actually not the radius that we're going to be trying to solve for. The radius we want is going to be here, A to C. I'm going to connect A to C there. That will be the radius we're going to try to figure out. So you want to draw this yellow radius here. And if you notice, I'm going to pull out this triangle here. There's A, there's C. This is what we're going to try to figure out, the radius in yellow. C to D is 6, this is halfway, this is 3. AB is 8, this is halfway, that's 4. And we are going to do a little A squared, B squared is equal to C squared. Okay, and that's how we're going to solve this. A squared plus B squared is equal to C squared, and I know the answer is 5 here. So this is 5, the radius is 5. And it's the same with either circle, whether I drew this one, because these are congruent circles.